The next thing to do is put a couple of capacitors on the input and output pins. Put a 0.1 microfarad ceramic capacitor on the input and a 1 microfarad electrolytic capacitor on the output. Remember to use caps rated higher than the voltages that you're working with. If you want to use more capacitance, that's fine too. These capacitors aren't always necessary, but putting them in there guarantees that the output voltage will be stable in almost any situation. Next, we set the output voltage using two resistors labeled R1 and R2. You can use this equation to figure out the output voltage. But to start out with, I'll show you the quick and easy way to use an LM317. Let's make R1 510 ohms, and let's use a 10 kilo ohm variable resistor for R2. Doing this gives us a constant voltage supply that we can adjust from 1.25 volts to 25 volts. But remember, your input voltage needs to be at least 2 or 3 volts higher than the output voltage, otherwise the output voltage is limited. For example, here I have a 12-volt lead-acid battery, and it's charged up to 13.5 volts. When I use it to power my adjustable regulator, I can get an output range from 1.25 volts to 12.4 volts when it's under a small load. The headroom I need is called the drop-out voltage, and it will always be given in the datasheet. So anyway, this is a very common way to make an adjustable fan speed controller, or test circuits at different operating voltages, or see how many volts it takes to blow something up. Alright, now let's say you don't want to use a potentiometer. You just want a fixed voltage using two resistors. Here's the formula I showed you earlier. If you're curious about how the equation is derived, read the LM317 datasheets from National Semiconductor and Texas Instruments. In order to simplify the equation, let's pick a value for R2. Let's make it 4.7 kiloohms, and now the equation becomes much easier. Next, you can rearrange the equation like this. Now you can find out the value of R1 based on the output voltage that you want. For example, let's say you wanted a 9-volt output. Plugging that into the equation gives you R1 equals 782 ohms, and R2 is still the 4.7 kiloohms we chose. So I put a 680 ohm resistor in series with a 100 ohm resistor, which gave me 780 ohms, and that was close